Welcome to lecture 40. So, in this lecture, firstly I will be interfacing with STM board the Bluetooth module. So, I will show you how we can use Bluetooth using STM, any microcontroller board. Here we will take the example along with STM board. This is the first thing I will do here in this lecture. Along with that, in previous two lectures we have introduced you with a device which is called accelerometer. With that device, as I have told you, we will be doing couple of experiments. So, we will be showing you how we can find out the orientation of a device. Meaning of orientation is that whether the device is lying flat, or is the device vertically up, or it is vertically down, or it is horizontally left, or it is horizontally right. Okay. So, these are the few orientation that we will find out how we can figure out the orientation of the device using the accelerometer. Okay. So, as I told you, firstly we will do the experiment with Bluetooth. We will first show how we can connect Bluetooth with the microcontroller board, and we already know the connection, how we can connect accelerometer. Then we will figure out the orientation of any particular device, and we will determine that, and that will be displayed in a mobile phone, which I will be connecting through the Bluetooth module with STM, that is established between these two, and finally we will show you the whole demonstration. So, Bluetooth, what is Bluetooth? We have already discussed. Now, the Bluetooth module that we are using here is HC06. Okay. This is the Bluetooth module that we are using. Okay. So, the connection is fairly straightforward with the Bluetooth module. So, this is the BCC which is connected to 5 volt. This is the ground which is connected to ground pin of STM. The TX is connected to D2 and RX is connected to D8. Similarly, these two are made, we have to build a serial connection between these two pins. So, we have to make one pin as RX and another pin as TX. Okay. So, this is the straightforward connection. Now, I will be showing you in the demonstration how exactly what will happen when you connect a Bluetooth module, but this is what you will understand when you connect it. After the connection, that means once you have a Bluetooth module with your device, which you will be connecting with the Bluetooth module that you have it in your mobile phone. Okay. So, when you try to connect these two, first of all, the Bluetooth module that you have interfaced with the STM, once the connection is built, the LED of the Bluetooth module will start blinking. So, you will see that the LED will start blinking. That means there is a connection established, okay, that the Bluetooth module is working fine. Next, when the device is connected, so the Bluetooth module will be used for communicating to device. So, when you will be connecting that Bluetooth module device which you have connected with the STM board along with your mobile phone Bluetooth device, because these two will communicate with each other. So, when you do that connection, then you will find that the Bluetooth device, it will stop blinking. That means the connection between the two devices has been established. Okay. So, these are the two things from which you can find out that in the first phase, when you just connect the Bluetooth module with a microcontroller, when it starts blinking, that means the connection is built. Okay. But when it is connected with another device, then it will stop blinking. So, these are the two things. When you connect with such module, you will find it out. This is the first. I will show you a test program where I will be connecting the Bluetooth module with STM board along with my mobile phone Bluetooth module, okay, and it will display some text. Some text from the microcontroller board will be sent to my mobile phone through Bluetooth communication. So, first of all, we have to do the serial communication. The name that I have given is Bluetooth, the name of this connection, which is with these two pins, that is D8 and D2. Okay. This is the first thing we have to initialize when we write the code. And then in the main, what we are doing, actually we do not require this. In the main, what we are doing, the connection which we have made with the name Bluetooth between D8 and D2, we will use this printf to print hello. So, once the connection is built with the Bluetooth module of STM along with the Bluetooth module of my mobile phone, okay, then we will transfer the data. So, the transferring data takes place in this way. The object that we have created, that is Bluetooth.printf, will print hello, then we will wait for 5 seconds and then we will print these few things. Welcome to Embedded System Design with ARM NPTEL 2018. Okay, this is just a message that will get displayed. Okay. Prior to this, let me tell you that I will be discussing everything when I demonstrate it, but let me briefly tell here itself that when we will be making the connection of the Bluetooth, we will require some Bluetooth terminal to be installed in our mobile phone. So, make sure when you do the connection, you have in your mobile phone a Bluetooth terminal, okay, that a particular app which will communicate through this STM Bluetooth enabled device. So, your microcontroller along with that Bluetooth become one device and your mobile phone is another device through which you will be making the connection. So, this is a straightforward code where basically we have just made this connection making one TX and another RX. Accordingly, we are sending some messages here. That is all we are doing. So, this is for the Bluetooth connection. Now, we will go ahead with the interfacing Bluetooth and the accelerometer module. So, this is fairly straightforward because we have already discussed about the Bluetooth, we have already discussed about the Bluetooth, that Bluetooth module connection. This is the Bluetooth module connection that I have already discussed with you. I have already discussed with you the accelerometer connection. So, we can make this connection which is connected to analog port A0, A1 and A2, and with the Bluetooth module it is connected to D2 with the TX and D8 with the RX, and BCC ground for the Bluetooth module and BCC ground for the accelerometer is connected here. This is all about the circuit diagram. Next, the first experiment. So, I will be discussing the codes first and then I will demonstrate. So, in the first experiment, we will determine the orientation of the device. Okay. So, recall our experiment that we conducted the previous lecture. In the previous lecture, we have shown you that we are receiving some values, right. Let us say 32,000 or 35,000, some x, y, z coordinate values we are getting. Based on that coordinate values, what we have to do, that we have to test when I put the accelerometer along with a device and we make it vertically straight, then what changes happens in which coordinates? Okay, that is what we need to check, and accordingly we will write the program. So, if that x coordinate value is in between this and this, or the y coordinate value is in between this and this, or the z coordinate value is in between this and this, then it is vertically up or vertically down. Okay. So, in this experiment, firstly we will look into the orientation of the device. So, this connection diagram with the Bluetooth module and with accelerometer will be the same. This is the Mbed code. Let us discuss. This is the serial connection for transferring the data. So, in the Bluetooth module, it will be displayed whether it is vertically up or it is vertically right. Then we will be connecting x, y and z coordinate to A0, A2 and A3. Okay, in this case I have connected to A1, A2 and A3. You could connect to any port of any analog port. This is first thing. Then what we are doing? We are reading the value. Okay, we are reading the three values, that is x dot read, y dot read underscore u16 and z dot read underscore u16. So, we are doing the following things to read the value. After reading the value, we need to check. Let us see what we will do next. Let us see what we are checking. What we are checking, x1 is the x out value, y1 is the y out value and z1 is the z out value. We have seen that the coordinate, when we are getting x1 in between this and this, y1 in between this and this, and z1 in between this and this, then the device is considered to be vertically up. Okay. After doing this, the Bluetooth.printf device will print the device is vertically up. Similarly, the next condition, if we get x1 value in the range of 42,000 to 46,000, y1 value in the range of 34,000 to 39,000 and z1 value in the range of 34,000 to 39,000, then we can see that the device is vertically down. So, basically when it is vertically up, so these coordinates if you see is the most. When it is vertically down, then these coordinates are having high value. Okay. So, this is just a representative thing that we have done it. When you do it, I have already shown you that how you will be looking into the values. You can, if you use Arduino, you can see it in the serial monitor, else you use CoolTerm where all these values will get displayed. Then you do the experiment. You hold the device vertically up and see what value of x, y, z coordinate you are getting. Okay. So, accordingly you can have the code written. So, this is the code written for our experiment through the way we got the values. Okay. You might get something different, so you have to try it out and figure it out. Similarly, there are few more conditions for if the device is lying flat. When it is lying flat, you see x coordinate value and y coordinate value are to some extent same, but the z coordinate value is the highest, okay, when it is lying flat. So, when this is there, then the device is flat. Let us move on. We have few more conditions. When the device is horizontally left, okay. When it is horizontally left, when we have the value of x1 and of course z also we can see in the range of 34,000 to 39,000 and y coordinate value is less here. Similarly, here it will be the opposite. This value is in this range, but y coordinate value is highest. Then it is horizontally right. So, it depends on how you are putting the accelerometer in the device also. So, you have to see that and you have to write your program accordingly. Then after every display there is a wait of 1 second, and after this there is a wait of 2 seconds, and everything is run once again. Okay. So this program, what we have demonstrated basically, it's like it is showing what is the device orientation. Okay. This is one application you can think of which you can experiment. Let me go to another experiment. In the previous experiment, it is we have done it in a fashion that whenever the device changes, and after every 2 seconds, it is displaying that the device is flat, the device is vertically down, device is vertically up. So after 2 seconds, it is getting displayed. Okay. So here we have just made one change where it will display the orientation of the device only when there is a change. That means, if the device is flat, it will remain flat. If there is a change from flat to vertically up or vertically down, then only it will get displayed in the Bluetooth module. So we have just done a little program change to incorporate this particular change. So let me show you what change basically I have done here. So this part of the code is straightforward, is the same basically, but we have taken two variables. One is flag, we have initialized it to 0. Another is old flag, which is also initialized to 0. Okay. So these are the two things that we have done. For all other things it is pretty similar. We have built a serial connection. Then A1, A2, A3 we have made the analog port, we have connected with XYZ out of the accelerometer. And then let us see the program here. What we are doing basically, that the condition would be pretty same if you see. Whenever we have either it is vertically up or it is vertically down, what is basically done is that we are initializing a flag. Okay. So in the first case the flag is 1, in the next case the flag is 2, in the third case the flag is 3, and flag is 4, and depending on it is vertically up, vertically down, flat, horizontally left, and then we see that it is again horizontally right with flag 5. Okay. And what we are doing in this check, we are seeing if flag, initially the flag value was 0, and then it will be in any one of these conditions, the flag value will change to either 1, 2, 3, 4 or 5, and old flag value was 0 initially. So if flag not equals to old flag, so for the first time this condition will be true because flag value is not equal to old flag value. Then what we will do, the old flag value will make it as flag. Okay. Now what is the old flag? Let us say the device was horizontally right, then flag value will be 5, and for the first time this old flag value was not equal to this value. So old flag value will become 5 here, and then we print the device is horizontally right. We wait for 1 minute and again we check flag not equal to flag value, but no, both are same, so it will not enter here. So whatever is displayed will remain as display, but whenever there is a change, let us say from horizontally right we change it to horizontally left. In that case what will happen is that this flag and this flag value will change. So whenever there is a change, then again through Bluetooth will display a text like the device is flat, etc., etc. Okay. So these are the two experiments that we will be showing you the demonstration right after this lecture. So there are other applications of accelerometer as well. So one of those application, a burning application is in health monitoring tools or health monitoring apps that we have in our mobile phones. So basically it will tell you that in a day how much time you have run or how much time you have walked, how much time you are sitting, various activities. Basically day to day your activities, you can keep a track of your activities that you are doing throughout the day. Okay? And also there is a very vital application that is fall detection for, of course, elderly women or men. So you see when old people generally have to stay back in their house alone most of the time, even if there are people to look after them, but there might be certain situations where we find them all alone. Okay? And under such condition, if nobody is around them and there is some serious issue like they fall down in bathroom or in house only, then how do their near ones will come to know? How will that be informed to their kids, their children, okay, or their relatives, anybody? So this fall detection application can be very nicely done using this accelerometer, but we need to keep into various false positive conditions, all the conditions we have to check. It should not generate some false alarm. Okay? So this using accelerometer, detecting for abnormal change in posture of a person is one of the very vital application that can be considered. You can take up as a project work maybe. Okay, so we have come to the end of this lecture. Now we will be showing you the demonstration. So in the final week, we have been working with one of the device, that is accelerometer. Okay, and what it does, etc., I have already explained. Now what I wanted to do is that the coordinates that we receive from this accelerometer, I want to send it to my mobile phone, let's say. Okay, we can do that. How do we do this communication? So we need to have some communication through which my mobile phone and this microcontroller, along with which is connected with the accelerometer, should communicate. So in this process we need a Bluetooth module. We all know the purpose of Bluetooth, how it works. Now the thing is that we will be connecting a popular Bluetooth module, that is HC06, where we will be sending some data from the microcontroller to my paired device, that is my mobile phone. Okay. So why we are requiring this? Because later what we will do is that we will connect accelerometer and will transmit the XYZ coordinate through Bluetooth to through Bluetooth to the mobile device. Okay. So let us see the connection that we can do, we have to do for this Bluetooth with STM board. Okay. So this is the Bluetooth module, okay, that is HC06. Okay. You can see it has got 4 pins. Okay. So the 4 pins goes like this. It has got an RX, it has got a TX, it has got a ground, and it has got a BCC. Okay. So this is basically the BCC, then ground, then this is TX, and then it is RX. BCC, ground, TX, RX. Okay. So this I will be connecting with the ground, BCC and TX, RX pin of this STM microcontroller with which we were working. First we will just connect these two and we will send data from this microcontroller to my device. Okay. So for doing this also you need one more thing, that you have to install a Bluetooth terminal. I am coming to that a little later. First, let me show the connection here that we have to do. So, as I said, this is BCC, which is connected to this one. This is ground, which is connected. This is ground, which is connected to the ground port of this STM board, and then we have TX and RX. The TX is connected to port 2, D2, and the RX is connected to D8. Okay. So, this is all about the connection. So, what I did, the 4 pins of this Bluetooth module is connected with the 4 pins of this STM module. Basically, if you think, what we are doing, we will be transmitting something from here and it will be received by this RX pin of this Bluetooth, right. As I said, now once you have this Bluetooth module connected, you also need a Bluetooth terminal. Okay. So, I have already installed a Bluetooth terminal. This is the Bluetooth terminal that I have already installed. So, here you can scan, and then it will scan and it will actually display what all devices are nearby. And if you see that, let me connect to, okay, let me power this. Okay, there is one more point, let me first tell, and then I will talk about this part of the connection. You see, when I connect, this LED is blinking. Basically, this is blinking, this is blinking. This meaning that it is ready for connection. Okay, it can connect to any other nearby devices. You can see it is blinking. Okay. Now this is my device. This is my mobile device, which I will be scanning first. Okay. So, it is, we are scanning this, and you just notice one thing, that the LED is blinking. LED is continuously blinking in this Bluetooth module. Okay. No device found, it says. Just a second. Okay. Now it is showing that there are some devices. Okay. And as I have already connected previously, so you can see that the paired device, it is showing up here, is this one. This one is the paired device here. So, I will just HC06, I will just click on that. And you can see a terminal is coming. Okay. Now, see what has happened. Once the connection is established with this mobile, the LED has stopped blinking. Okay. Now, I will show you once more by switching off the connection. Let us say I switch off the connection, and you can see that the LED has started to blink again. So, it is ready for connection, and when I again connect, it has stopped. That means it has connected. Now, I will send two messages from this particular, I will send through Bluetooth from this microcontroller to, this mobile. Okay. Let us see what message it. Okay. So, you can see hello came, followed by welcome to embedded system design with ARM NPTEL 2018. Okay. So, this is just a sample data that we are sending, you can send anything. Okay. So, this is how you can actually connect a Bluetooth module with any other device, and then you can send the data through your microcontroller and through this communicating device to any other mobile device or so. So, here I have just sent these two data, that is hello and welcome to embedded system design with ARM. So, this is the simple connection that I have shown, that how you will be connecting a Bluetooth module with your mobile. Now, what we will be doing, we will be integrating this part of this Bluetooth module along with accelerometer. Okay? And we will see that we will be taking up one more experiment on accelerometer, which will show something using this mobile. Today, I will show you another experiment where I will integrate accelerometer along with the Bluetooth connection that I have already shown, and then we will analyze the orientation of any object. Okay. So, what I will be doing, the accelerometer will be getting the XYZ coordinates, and through Bluetooth, now the accelerometer will be receiving the XYZ coordinates. Then the microcontroller will do the needful, it will analyze it, that whether the coordinate received signifies that the device is flat, or the device is vertically up, or it is vertically down, or it is horizontally left, or it is horizontally right. Okay. This is the first set I have already discussed, that I will be showing with accelerometer, and then I will be showing another experiment where it will not send the message repeatedly, rather it will only send when there is a change in orientation of the program. Okay. So, you see that this is the accelerometer. Okay. It has got 5 pins. Okay. So, these pins are BCC, X, Y, Z and ground. So, one is BCC, then X, Y, Z and then ground. Okay. So, I will be connecting this with the breadboard where I have already made the connection. So, you can see this I have connected with BCC, this I have connected with ground, and this is XYZ. So, I will just put this down here, and Bluetooth connection we have already seen, and you can see that the Bluetooth, this red light is blinking, the LED is continuously blinking, meaning that it is ready for connection, but the device has not connected yet. Okay. Now, the way we have made the program, when we place the device in this fashion, meaning it is flat, when we will put it in this fashion, so this one is basically the up one, it will say that it is vertically up. If you make it like this, it should say vertically down. Okay. And then if you turn left, it will say horizontally left, and when you do this, it will be horizontally right. Okay. So, let me first do the needful. Okay. So, this is the connection with Bluetooth we have already seen, and this is just the connection I have made with this accelerometer, and this will be my horizontally, this is vertically up, this position should be, okay, and this is flat. So, I just kept it in flat position, and I said there are two set of codes that we have put. For one code, it will continuously send that what is the orientation of this particular device. This, let us say this is my device, and in the next program, whenever the orientation changes, then only it will actually send the data through this Bluetooth module. Okay. So, let me first connect to the Bluetooth module the same way. So, it is still blinking, you can see that, and now I will do the connection, and you can see that it is now stable. And now see what message is getting displayed. The device is flat, so it is lying flat. Okay. Now, I will make this device vertically up. So, it is vertically up now. Okay. Now, I will make this device vertically down. So, maybe just a second. So, now I have made, now this is showing that the device is vertically down. Okay. And the device is flat now. Every 2 seconds it is sending this. Now, again I have made it vertically up, which is displayed in this terminal, and then I will make horizontally left. Okay. I have turned to the left side, and now I will make it horizontally right. So, you can see that it is now horizontally right. So, these are the few orientation which we have made with respect to XYZ axis. We have already seen that what value will receive on XYZ axis, and depending on how we have put the accelerometer here, we have made the code accordingly. So, the way you put the accelerometer, it depends largely upon how you are actually putting the accelerometer and then receiving data, and then how your device is put up. Okay. So, these are the few things we have to take into consideration when we do this. Okay. Now, I will again disconnect. So, I will disconnect, and you can see that it has started to blink again. This LED is blinking again. Okay. Now I'll again dump another code where only it will change if the orientation of this particular device changes. Okay. It will not change, or it will not send the device to this mobile through Bluetooth if the position does not change. If the position changes, then only it will send. Okay, let me first connect. It is still blinking, so now it is not blinking. So the Bluetooth connection has been made with this device. Okay. Now I am not changing the device. Now let us say I have changed. Device is vertically up. Now if you recall, in the previous experiment, it was continuously displaying that it is vertically up in 2 seconds, but now I am not displaying that. Okay. I am only displaying when there is a change. Now you see message has been sent that the device is flat. So whenever there is a change in orientation or change in position of this device, that is the orientation, then only there is a message coming up, otherwise no. So continuously we are not sending something, we are only sending something whenever there is a change in this particular device orientation. It is up, now it is horizontally right, now it is up, and after let us say few seconds I will just put it down. So device is flat, and it will not send any message unless and otherwise there is a change in the position of this device. Okay. The code for the same was already discussed. I have just shown the demonstration. There are various applications of this accelerometer. I have already discussed previously, like you can even track the number of steps a person is walking in a day. Okay. So we have already seen that when we move the accelerometer in various position in various ways, the XYZ value changes. Okay. And when we are sitting or we are moving in a very slow position, how the value changes. So you can actually take all these things into consideration while tracking, like for tracking the activity, basically the activity, human activity. So you can track human activity using this accelerometer. In our mobile phones, this accelerometer is there, and there are many other applications, very good application, like fall detection for elderly women, elderly person basically, that can also be done using this accelerometer, and there are a couple of things people have already done using this accelerometer. So you can also try out doing some other examples, other experiments. Thank you.